Hello and welcome to the series of videos on logistic regression. In this video we are going to see that if we use this formula as a cost function, the cost function will be a convex function. It will be a convex shape. It will have the convex shape. Now there are two ways of proving it. One mathematically. So I'm not going to discuss the mathematical formula. There is because it's very calculus driven. So I will just brief how we can prove that. So to prove any function is a convex function or not, we have to do the differentiation of order 2, double differentiation of the function, and in respect to the value against in respect to the variable. So this is the, in this case this function is dependent on theta. Theta is the variable, so we have to differentiate this function. We have to get the double differentiation of this function, and if the double differentiation is always positive, whatever value you take, it is always positive or always negative, then it will be a convex or concave accordingly. So that's a mathematical way of proving. So I'm not going to discuss that. Rather, we are going to show this with some data point. So what I have done that, okay, let me start my R. So what we will do, first let me show some data. So I have got some data points. So this is I have some data here. Let me show the data. So this is for, as we are going to use visualization, and for visualization can be done in the 2 dimension, and that's the best way. So we are going to have only one variable. So x here has one variable, and and here is the y, that is a target variable. So y is either 0 or 1, and we have the respective x here, right? So okay. So that's the data. Now what I said, we know the, for this particular data, if we apply the logistic regression, I know the value of theta where the minimum will be there. So that means I am aware of this value of theta. So what I will do, that I will start from somewhere, let us say here, and at this point I will calculate the loss. Then I will increment the value of theta a bit. Then I will calculate the loss. I will keep on incrementing this, and I will traverse till like this kind of range of theta. So by this I will have the value of theta, and I will have the value of the cost at the respective theta. Then we will plot the value of cost on the theta, and let us see how the graph comes. So that's the idea. That's how I'm going to. That's how I plan to show this. So since I'm aware of what is the minimum value of theta, so what I'm going to do, I'm going to pass the data set dt and the value of theta, which I know where it is minimum. That means this value. Okay, and then what I'm going to do, assume that, as I said, that I will travel I will take the different value of theta, let us say from here till here, and this is a range of, let us say I have to take 5,000 different steps. So that is the number of total steps I'm taking here, 5,000. So in that case, if this is the theta, minimum value where theta is, the theta where the minimum value of the cost function is, then I have to take 2,500 steps this side, and then 2,500 steps this side, right? So that's what I have done here. Left side I have to take 2,500 of steps, and what is the step size? I have taken the step size as 0.001. That's very small, so that we can have a smooth curve whatever we get. Okay, so I have stored the value of b, value of the theta in b here, and the first value I am taking as an initial value of b, and there I am doing that b means this value, and okay, so that's what we are going to do here in R. So once we initialize the value of B, okay, this is the data frame where we are going to store the value of uh, uh, theta, means B, and at that respective B, what is the total cost. So as we have to we have to start from somewhere here, and then each step we have to take and increase the value of theta and calculate the cost. So we are going to use a for loop here. So we'll start from 1 and we'll take the 5,000 of steps, total steps of 5,000. We'll increment each step by 0.001. And what I'm doing here, that I'm taking the data frame, my original data, and in that, if we see, if we refer our steps what we have shown in the logistic regression, first we have to calculate the value of Z. So that's what I'm doing here. Then we have to calculate the value of P. That's what I'm doing here. And then the loss function has two parts. One, when y is 1, and second, when y is 0. So I'm calculating the here when y is 1 as loss 1, when y is 0 as loss 0, right? And this is the complete loss. This is the same as what I have shown here. So this is the loss of one observation, right? So and so the total cost will be the total of all the loss divided by number of data points by what we have, average of the loss, total cost. Total cost is aggregation of the loss, right? So that's what I have done here. We have taken the average of the loss, and I'm storing those values whatever we get here, that which iteration 1, first step, second step, third step, like that, the value of B, then value of the cost at that particular point, and then I'm incrementing the value of B with step size whatever I have taken as 0.001, and that's how I'm going to use the for loop to calculate the cost at different value of B. So let me execute this function which calculate the cost at different value of theta. So to that function I'm entering my data set which I showed in, when I started the video, and this is the theta I know at this value. I know by using the logistic regression function, which I will discuss later. So that is what I'm doing here. So I'm passing these two value and I'm calling that function. So let us do it. So now it's calculating the value of cost at different point of theta. Now let us plot. So what I'm plotting here, I'm plotting B, means theta, in the x-axis and cost in the y-axis. If we recall, this is what we have done here, right? X-axis is the theta, y-axis is the total cost. Now let me plot it. If we see, this is the cost function what I have. Due to limitation of the time, I'm not able to discuss this graph. We will continue from here in the next video. Thanks a lot for watching. Please follow my next video.